This lesson is to help you solve equations that involve radicals. When you first learned how to solve equations, probably your Algebra 1 teacher talked about inverse operations. You learned that addition and subtraction were inverse because if you had 4 and then you subtracted 4, you got back to 0. With multiplication, you learned that multiplication and division were opposite because 4 divided by 4 equaled 1, the identity element for multiplication. When you think about radicals, think about that the square root of x, if I square that, I get back what I started. I get back with 2x. Same with the cube root of x. If I cube that, I get x. Some of our problems will be a little more difficult than that. You'll have something like the cube root of x squared. Well, how do you find the inverse of that? Well, think back to a previous lesson. We learned that the cube root of x squared could also be written as x to the 2/3. Well, if I wanted to get back to x, what I can do is take the 3/2 power of that. If I have x to the 2/3 and I take the 3/2 power, that gives me x to the 6/6, which is really just x. So I get back to what I originally started with. Let's see how that works in equations. For this equation, I would start out, I want to get so that I just have the radical alone. So I'm going to divide both sides by 3. That gives me the square root of x minus 5 equals 2. Now I really want to get to the x. So to do that, I'm going to square both sides. So that, in essence, gets rid of the square root because the square root and squaring are inverse operations. So on the left side, it gives me x minus 5, and on the right, 4. Use my regular solving skills, and I get x is 9. Now you really need to check these problems for extraneous solutions. If I do a check on this, I'm going to put 9 in for x. So 3 times 9 minus 5, does that equal 6? 9 minus 5 is 4, so 3 times the square root of 4 is that 6, and it is. 3 times 2 is 6, so it checks. Okay, you write down problem number 2 and work it in your notes. Then come back and check your answer. Okay, for this problem, I noticed that I had a cube root, and so the inverse operation would be cubing. So that's why the powers of 3 are there. If I check my work, I would have the cube root of 214 plus 2 minus 4. That should equal 2. I get the cube root of 216 minus 4. The cube root of 216 is 6. 6 minus 4 is 2. Okay, let's try one that has fractions. For number 1, again, I want to get to the point where I just have the part with the radical, and that would be, in this case, the x to the 2/3. So I'm going to add 4 to both sides. Now I need to get rid of this 2/3 power. So in order to do that, I just want to be left with 1x. So I'm going to take the 3/2 power of each side. On the left side, that gives me x to the 6/6 because I multiply those powers, so that's just x. Now on this side, it's a little easier to see if I write this in radical notation instead of the exponential notation. Remember, the bottom number is your root and the top number is your power. So that will give me the square root of 25 cubed. Well, the square root of 25 is 5, and 5 cubed is 125. So let me check that answer. So here's my check. 125 cube root, and I want that squared, minus 4, and I'm trying to see, does that equal 21? Well, the cube root of 125 is 5. 5 squared is 25, and 25 minus 4 does equal 21. You try number 2, and then come back and check your work. For this problem, you should have gotten that x equals 12. Notice that we had the 1/3, or that would be the cube root of the 2x plus 3. So to rid myself of that cube root, I took the power of 3, or cubed both sides. That cleared out that cube root, leaving me with just the 2x plus 3. Now to check my work, I'll put 12 in for x, so that's 2 times 12 is 24 plus 3, and that's to the 1/3, or the cube root, and the cube root of 27 is 3, so 3 minus 5 does equal -2. Notice that this problem has 2 roots in one equation, and they're both to the 4th root. So what I'm going to do is take the 4th power. So I end up with 3x plus 1 equals 2x plus 2. Subtracting 2x from both sides gives me x. Subtracting 1 from both sides gives me 1. So to check this one, the 4th root of 3 times 1 is 3 plus 1 on the left side. 4th root of 2 times 1 is 2 plus 2. So that checks because it's the 4th root of 4 does equal the 4th root of 4. Okay, one last example to work through. Here I'm still wanting to get to my x, and there's no way to combine these two since one is in the radical and one is not. So what I'm going to do is I'm going to square both sides so that I can get rid of that radical. So on the left side, that gives me 2x minus 3. On the right side, remember that this is a binomial squared. So that means x minus 3 times x minus 3. So I have to FOIL this out. So that will give me x squared minus 6x plus 9. Now if I combine like terms, I'm going to subtract 2x from both sides. So that gives me minus 8x. Add 3, and that gives me 12. When I have a quadratic, The easiest way to solve is to try to factor. And I can factor this as x minus 6 times x minus 2, because x times x is x squared, x times minus 2 plus negative 6x gives me the negative 8x, and then negative 6 times negative 2 is 12. To get my roots here, x minus 6 equals 0, so x is 6. X minus 2 equals 0, so x equals 2. So I ended up with two answers. I ended up that x equals 6 and 2. So let me check these. The square root of 2 times 6 minus 3 should equal 6 minus 3 if 6 is a true root. So that gives me square root of 12 minus 3, which is 9. The square root of 9 is 3, and 3 does equal 3. So let's try 2. The square root of 2 times 2 minus 3, and we're testing to see if that equals 2 minus 3. So the square root of 4 minus 3, 4 minus 3 is 1. The square root of 1 is just 1. And so that doesn't work because this is a negative 1. So 2 is not one of our solutions, and that's called an extraneous solution. In other words, it's a solution where we did all the right math. We didn't do anything wrong. It's just it doesn't work. And you'll find that that occurs often when you have radicals involved.